Okay, so last video it was the two kinds of forces, the eight forces in total, and how to draw free body diagrams. Now we're on to the laws, Newton's laws. There are three. The first one, law of inertia. It states that an object at rest will remain at rest, and an object in motion will continue to move at constant velocity unless acted upon by an unbalanced external force. The in mathematically, you can write it as summation of all forces equals 0. Same with the components. So here, there's a solution. We'll put this at the side, just remember that. So summation of forces is this. So we're using x. So weight cos W cosine theta, that's for weight, that plus T1 cosine theta 1 plus T2 cosine theta 2. T1 W cosine theta is cancelled because there is no x component for the weight. T2 becomes negative because let's say this one T2 here is in the x direction is pointing opposite, so the magnitude's negative, not the degree. But if you want this to be plus, this one would not be 60. This one would be 1, if I'm not mistaken. That would be 150, but we'll stick with a negative for now. Yeah, not 150, sorry. 240. Sorry, 240. So since this is negative, we can transpose this to the other side. So it's, since it equals 0, transpose to the other side. So T1 cosine 60 equals T2 cosine 60. We can cancel cosine 60. So T1 equals T2, which we can just write as a whole for as T. So for the y component, W sine theta plus T1 sine theta 1 plus T2 plus T2 sine theta 2, which also equals 0. Now up here, force of gravity or weight equals mass times gravity or acceleration. But since this is weight, acceleration is negative 9.8 meters per second squared, and mass here is 3.0 kilograms. So we multiply that, it will become negative 29.4 newtons. Down here, we replace that. Since T1 and T2 are equal, we can just replace that with T. So transpose the weight to the other side, it becomes positive. We can add these into 2t sine theta, and theta becomes 60. So we isolate t by dividing both sides by 2 sine 60, and what we get is around 17 newtons. That is an example for first law of motion. Now the second law of motion, law of acceleration, is when it is when it is not in equilibrium, when it is unbalanced external force. So there is an external force, unbalanced. So there's acceleration because of the force. So the summation of all forces does not equal 0, but the but equals mass times acceleration. Same with the components. So we know kilograms. So we know from this here that kilograms multiplied to meters per second squared equals newtons. So 1 newton of force is equal to 1 kilogram meter per second squared. So this example we have a boat with two mule engines pulling it at 55 degrees. So each engine exerts 150,000 newtons at an angle of, like I said, 55. And we need the magnitude and direction of the sum. So we just add, since this is the free body diagram of the mule engine forces, the y components cancel each other out. If you can imagine that, please do, because they're the same magnitude but different. Um, they're the same magnitudes. The y would cancel out, so all we're left is with x. We add the 2x. This one is how to get f1x or f2x, since the two have the same angle uh, and force. So what it equals to is around 86,036.47 newtons of force. Am I right? That's for one of the forces, and then if we add this with itself, it will become this. So we just times 2. Okay, so that's the example for second law of motion. Now for the third law of motion, the first two laws has only one object and external forces, but this one has two external forces but two objects. The law of interaction, or the action-reaction law, states that when an object exerts a force on another, second object exerts an equal and opposite force back on the first. So there are two objects and there is one force. Object A and object B are the two objects. Object A exerts a force on object B, and object B will exert the same force, just opposite direction, onto A. That's why the forces do not cancel. According to the law, all forces occurs in pairs. Each force in an action-reaction pair has the same magnitude. Each force acts in the opposite direction in line with the other force of the pair. They're just opposite direction. Each force acts on different bodies of interest. This is important. This is very important. Different bodies of interest. So for the sample problem here, two masses, mass 1, which is 13 kilograms, and mass 2, which is 12, are connected by a light inextensible string passing over frictionless pulley. Basically just saying pulley with string that cannot break. Find unbalanced force, acceleration of the system, tension of the string, and speed of mass 1 after it moved 2.4 meters. So we have the given. We have the given mass 1, 13 kilograms, mass 2, 12, weight 1, calculated by multiplying to negative 9.8. So that's negative 127.4 newtons. Weight 2 is negative 117.6 newtons. Force 1 equals mass. Force 1 equals mass sub 1 times acceleration of sub 1, and which also equals tension plus weight 1. So we equate the two and then isolate t, so it becomes so weight transfer, so it's negative. Same thing with here, except the acceleration is negative of a, because it's negative of a, because here it says already A and A, they're just moving in the opposite direction, so negative direction. So since the two are equal to T, or tension, we can by extension equate the two with each other. So mass 1 times acceleration 1 minus weight 1 equals mass 2 times negative acceleration 1 minus minus weight 2. Excuse me. So 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 we transpose mass 1, we transpose we transfer. So mass 1 times acceleration 1 minus quantity mass 2 times negative acceleration 1, and that equals weight 1 minus weight 2. So since there's negative here, since there's a negative in acceleration, we can turn the negative in the front to positive. Then we isolate the we this sorry we factored out the acceleration, and we divided both sides by mass 1 plus mass 2. The unbalanced force is on the top, so that's weight 1 minus weight 2. So total net force is weight 1 minus weight 2, which is negative 9.8 newtons. So unbalanced force kept out. Now, for B, which we're looking for the acceleration, acceleration is force divided by mass, or just this. So negative 9.8 newtons over 13 plus 12, which equals which approximately equals to negative 0.39 meters per second. Now, if we put into consideration, we turned acceleration 2 into negative acceleration 1, so they're supposed to be equal, except negative. So the acceleration of mass 2 is positive 0.39 meters per second squared. So for C, we're looking for the tension. We get one of these two, let's use one, and 13 kilograms times negative 39, 0.392 meters per second squared, minus negative 127.4 newtons, and that's the tension, which approximately equals to 120 newtons. So for D, acceleration, the speed after 2.4 meters, kink in y equals this. We're looking for final, so we use this equation. Since there is no initial velocity because it was at rest, we just cancel that out. So square root both sides to get rid of the square here. So square root of 2/8 tangent y. So that becomes square root of 2 times negative 0.392 meters per second squared times negative 2.4 meters. We put that in the calculator, and that's about negative 1.4 meters per second. That is the third law, and that is it.